The time is now 2 o'clock, so we will go ahead and get started. Thank you so much to all of you for joining us for today's webinar, How to Teach 3D Printing Remotely. My name is Desmond Martin. I am the program coordinator at NextWaveSTEM. My professional background is actually in mechanical engineering, but I've worked in education both as an entrepreneur and at NextWaveSTEM for over 10 years. And it is my pleasure to have each and every one of you with us. I'm really excited because we understand that recent events of the past 3 months have necessitated that we do our learning remotely and at distance. Things that we had plans for, some really, really exciting things that we might have had in mind in terms of our STEM education have been derailed. And I am here to encourage you that while things may not be the way that we want them to be, we still have awesome opportunities to empower our students through STEM generally and through 3D printing specifically. If this is your first time with us in the NextWave STEM webinar, welcome. We are so glad to have you. If you have been with us previously, then you already know our ground rules accordingly. But I'll repeat them for the benefit of our first time guests. Today's webinar is a webinar format. That means that we won't be able to see your face, even though we know that you are camera ready, looking amazing on the other end. In the same way, we won't be able to hear your voice either, but the chat and the Q&A functionalities are open today. So if at any point during the course of the webinar, you have any questions, any concerns, anything you want to share, you are more than free to drop those in the chat. If you have a question about anything, you can put your question in and we'll make sure to get that answered live and on air. In a little bit, my colleague Segundi Chigani will be joining as a panelist to help moderate the chat session. That means that if something's put in there and I miss it, Segundi will catch it, and she'll also be able to add helpful information as we go throughout the course of the webinar today. The second bit of housekeeping that I always like to perform is for our Illinois teachers. Today's webinar will be counting towards ISB PD credit hours. That means that at the conclusion of today's webinar, you're going to be receiving a follow-up email from me. And that follow-up email will include a couple of things. It will include your personalized invite to our next webinar that's next Tuesday. It will also include the certificate of your PD credit hour completion. That certificate should also serve as proof that you joined us for those of us who are outside of Illinois, even though I might not know specifically what your state's reporting requirements are. The second thing that you'll receive is a copy of the slide. We're going to cover a decent amount of material, and we want to make sure that you can have the slide deck as a reference to look back on and hopefully guide you along your way. In that same vein, we're also going to be including a link to the recording of today's webinar. So you don't have to worry about just being out in the cold. That's something that you will receive today. And that link will also include a link to the previously recorded webinar series that we've been doing in NextWaveSTEM. So we're hoping that you'll have everything that you need to kind of be going along the right direction. So with all those things being said, I also want to say that I am excitable. And when I get excited, I can speak more quickly than what's useful. If you need me to slow down, if you need me to go back and repeat something, feel free to jump in the chat and let me know that I'm going too fast. And for those of us who are here in the chat, I dropped in a message a little bit earlier, but I'll drop it in again. We'd love to know more about you. So if you want to just post the school district or just where you're from generally and what you teach, we would love to know a little bit more about you. But while that chat is open and those fingers are typing away furiously, I'm sure, we will go ahead and get started. So a great place to begin is at the beginning. And the beginning really is speaking to NextWaveSTEM. who we are as a company and why we exist. NextWaveSTEM, at its heart, at its core, we are a company that believes in young people. We are a company that believes in promoting STEM in young people. And we are a company that deeply believes that teachers are integral to the process of promoting STEM in young people. Um, our world is going to be facing some huge, completely huge, seemingly insurmountable challenges in the years ahead. And in fact, our world, our country was facing some challenges before there was a global pandemic that was changing so much of our lives and the way that we even educate. Um, we know that there's going to be a future generation of scientists and mathematicians and technologists and engineers and all kinds of STEM professionals who are going to have to rise to meet that challenge. So we want to make sure that we equip them and that we're equipping them from a young age. More than anything, we have to empower our teachers, give you the skill set, show you how easy learning about STEM actually can be, provide you the curriculum, the training, the equipment, the resources that you need to teach your students from a young age till the time they're really ready to matriculate to the college level. How to empower your students with STEM. That's what we're passionate about at NextWave STEM. We are a small but scrappy team who believes in you as teachers and believes in our next generation of STEM learners and STEM professionals. And so with that being said, we're here to continue to empower you when we think about 3D printing online. And we kind of have our goals broken out into two things specifically. We're going to cover a lot. Some of these things, if you're familiar with Tinkercad, you may have seen before, and you may learn some new things. But the first thing is we want to teach you how to use the Tinkercad cloud 3D design application to build some skills in 3D design with your students. When we think about 3D printing, the first thing we actually need is something to print. I like to break down 3D printing as a three-step process whenever I explain it to educators. You have the design where you are actually generating a three-dimensional object digitally. The second part of that is the slicing. Slicing is where we take the raw numbers of our three-dimensional object or objects and translate that into code, into specific instructions that our actual 3D printer will follow to produce our object. That part we won't talk so much about today. We'll touch on it a little bit when we also talk about the third part, which is the physical printing. How do we physically make our object from whatever material that we're using, in whatever size we might want to use, or in whatever time frame you want to use as well. Today, we're going to focus on the first part of that process more than anything and touch on the last two parts of that process from the remote standpoint. But secondly, we want to think about, okay, what would this actually look like in distance instruction? And that all comes down to an instructional model. What are ways that we can approach tangibly our students who will maybe only have access to computers or in some situations smartphones, and make available to them instruction in 3D printing, knowing full well that they may have no access to a 3D printer at all. There are some really clever things that we can do to really encourage our students to bring together all the amazing integrated skills that they'll learn in 3D printing. So we'll go ahead and we'll jump right in because we've got quite a lot to cover. So the first thing we want to start with is getting into the flow of design with Tinkercad. Tinkercad is an online free. I need to say that once, free. I need to say it twice, free. The third time, absolutely free piece of software that's available for your students as long as they have an internet connection. It lives in the cloud, very similar to the way that Google Drive or Google Docs would. And it will allow your students to use some basic design skills to generate 3D objects. And with those 3D objects, You'll be surprised that they can generate really, really complex objects. But before we get our students designing, we have to think about how we want to use this as a teacher. What can I do? What can I manage? How can I keep things civil and organized for myself and for my students? How can I actually manage my students in a 3D space? Well, we've got some multiple options. So pre-lesson, before you ever get started with Tinkercad, the first thing you want to do is create your Tinkercad account. And the second thing you want to do is creating your classes. And I'll show a little bit of an example of what this looks like. Um, there are two options with creating classes. You can create a brand new class that where your data lives specifically in Tinkercad, or you can also integrate your Tinkercad classroom directly into Google Classroom if your school uses Google as their learning management system. So I'm going to pop over to Tinkercad and show you what that looks like. This is our Tinkercad editor. I'm not so concerned about this. We will come back to this model a little bit later, but at any time I can click on this Tinkercad dashboard button, just this multicolor logo, and it will take me, after saving my work on this page, take me to this top page of Tinkercad that shows the dashboard. You as an educator, all your students will have this dashboard. It will show you designs, but it also gives us this convenient feature that's really powerful ability in these menus. The ability to access personal learning for ourselves, classes, something we'll come back to a little bit later on. The gallery where other designers have added their 3D printed designs that we can look like. A blog, just updates from Tinkercad about what their product is doing. That becomes really helpful. But more than anything, we want to teach. So clicking on that Teach tab tells us a little bit more information that's going to be extremely useful to us about how to manage our Tinkercad classrooms and how to sign in students to Tinkercad. This is our resource center. If you're starting with Tinkercad for the first time, you're set up your account as a teacher, I would almost say it's a prerequisite that you navigate to this page first and learn about some of the ways that you can manage your classroom. Because once you get that information, then you're actually able to set up classes and manage your classes. So I'm actually going to click on this classes tab now and show you what a class in Tinkercad will look like. Currently, I have an empty set of classrooms. I've got no, well, actually, I do have a classroom example. Well, my page just scrolled down. So I've got my classroom example. And in this case, I'm going to create a brand new class. When you log into Tinkercad for the first time, this will be empty for you. But for me, what I'll do is I'll create a new class and I can name the class anything I want to. So in this case, it will be webinar example. We can specify our grades. In this case, it's other, since we have a variety of diverse learners. And I'll also pick other as our subject. This is really beneficial for you in your organization and categorization as well. I will then create the class. And now I have my webinar example class. Clicking on webinar example opens my classroom, and we can see currently I have no students in the classroom, but that's fine because I can add students really, really easily. Clicking on the add students button gives me the ability to now add students. So let's say I have Matt, Mark, Luke, and John in my class. See that it will import directly kind of in the background there. It will import to my class, or if I have, like I know everyone has, it's a really easy Excel spreadsheet roster of my students. I can all of those students' names into my class and keep going. Now, the awesome thing about Tinkercad is that it generates two pieces of information for us that are going to be helpful to students when they log in. I'll go back to my class. It has the name of my student, but it also will give me a nickname. The nickname is what the students are going to need to know in order to log into your class in Tinkercad. I just got a really good question in the chat here from Melissa. Is there an auto import option from Google Classroom? That's a really good question, Melissa. I would need to look into that to see if your students will auto import. What I do know is that if you are a teacher with students nested underneath you in Google Classroom, when your students use their Google associated account, their school account that's associated with Google, and they log into Tinkercad, it should automatically place them into the class that you have set up in Tinkercad. That's my understanding. But what I can do is follow up with you so that way we can get you that specific information. We'll certainly let you know. So once your students have logged into uh, once you have actually pulled your student roster into Tinkercad, they will have their names, but they'll also have a nickname assigned. That nickname is going to be important because it protects your student's identity, just information and COPA security. But also when they log in, they will need to include a class code. I just clicked on the class code button. Students will log in. You can push this class code out via chat if you're using Google Meet or Zoom to conduct your class. You can also send it by email. Students will log into Tinkercad with a specific link that has the class code and then enter their nickname to be able to join your class directly, or they can go to a more generalized link, Tinkercad/join class, enter the class code, enter the nickname, and then they'll be placed into your class. You can do this specialized URL, or you can do the general URL. There are a couple of different ways of doing that, just so that you have some flexibility. Um, so that way, you'll be able to make sure that your classes are set. That's actually really important, just to make sure that we keep things nice and in order. So really useful function to have. There are so many things that we might use in terms of tools that we won't be able to save. We want to make sure that you as an educator have access to your students' work to be able to evaluate and to help. So far, we have covered that you can create your own classes in Tinkercad and that they will integrate with Google Classroom. So that basic setup becomes very important and just useful for us later on. The second thing that I mentioned is that in Tinkercad, it's really important for you to build your own skills first. Tinkercad is simple. I wouldn't go as far as to say that it is easy. But it is simple. And once you get into the flow of using that tool, you get really good really fast. And you'll see that with your students. Take advantage of the free resources that you have available for you to learn Tinkercad. Tinkercad has lessons. There is an associated makerspace website called Instructables. Instructables also lives under the parent company. Tinkercad is an Autodesk product, and so is Instructables. There are lessons there for you as well to learn how to use Tinkercad. And one of those other things that we're going to be including as a part of your participation today is access to NextWaveSTEM's curricula. That is helpful for teaching you more about how to use Tinkercad. You can click into these links in the webinar slides that I'll be sharing with you, and it will take you directly to the web page that you need to go to. I'll show you the classes in Tinkercad, so I'm going to navigate to the other tab. And away from this classroom code, for you as an educator, what's going to be really useful is when you click on the Learn tab. And the Learn tab will take you to a series of starter projects, things that are very easy for you to learn the basic controls and mechanisms of Tinkercad. But there are also full-blown lessons for you, building some simple objects to Larger projects. Larger projects are kind of taught alongside the instructor in Tinkercad um, via video, pre-recorded video. Very, very useful if you've never done Tinkercad before, and you'll see that you'll pick it up and start to roll really, really quickly. So once you set up your classroom and then you've built your skills a little bit, you that hour or two or maybe more. If you're like me, when I learned 3D design, I kind of got an itch and kept going. Then you want to expand your ideas for design. This is thinking about the kind of things we can actually build with our students, specifically those things that we can design and build with our students that they materials to construct that aren't a 3D printer. And that's where Tinkercad becomes a really, really powerful tool for us. And so in building those design connections, there are a couple of categories. One thing I want to show you in the Tinkercad editor is Minecraft and Lego mockup. But I also want to show you some useful shape categories when we think about things that your students use to design really usefully. This will get into what you base your lessons around when you begin your 3D printing class with your student. But these are really useful shortcuts to expand the things that your students can do in Tinkercad. So the first thing I want to show you is Minecraft and Lego mockup. For that, I'm going to navigate back into Tinkercad. I'm going to go back to my dashboard. And just like that cooking show, I have something a little bit made ahead of time that I want to show. So I'm going to click on this object and say tinker this, and that will open once again my 3D design space where I had my 3D object. Just a little bit of background, and I'll talk a little bit more about this. This 3D object is the lunar lander from the Apollo missions. This particular object is a 3D scan of the lander that went into space. And the source for this 3D scan is actually the Smithsonian Institution. A couple years back, well, not even a couple years now, a couple of months back, they did high definition three-dimensional scans of objects and added them to Tinkercad so that students will be able to see these objects kind of in this three-dimensional space right in the computer screens. We'll talk a little bit more about some of those other objects, but Melissa, I'm a huge fan of the lunar lander as well. So we've included that as our example today. Our view cube allows us to actually rotate and see that lunar lander from a bunch of different angles. We can even look at it from the underside as I'm manipulating, and I can zoom out and zoom in. One really useful thing with Tinkercad, and I'll actually adjust the view. One useful thing with Tinkercad is this ability to not just see in high fidelity 3D, but also think about other media. In the upper right-hand corner of the Tinkercad design screen, I've got highlighted this option for 3D design. To the direct right of it, there is this button that says blocks. And when I click on it, what that will cause to happen is whatever 3D design you have will be rendered in Minecraft blocks. And we can change the fidelity of those blocks. So right now, fidelity, students are able to see kind of what their design might look like if they built it in Minecraft. And we can go into higher levels of fidelity as well. One amazing thing about the Microsoft product Minecraft is it expands our students' abilities to think in three-dimensional space in some really creative ways. And modeling actual real-world objects in three-dimensional space, especially from the architecture standpoint, becomes an exciting and engaging activity for our students as well. So at high fidelity and zooming in, we can kind of get a sense or give our students a sense of what their object would look like if they decided to design in the world of Minecraft. Kind of cool, kind of fun for our students who really love Minecraft. It's a hugely popular game. I'm going to zoom out, however, because directly to the right of our blocks function, there is something that looks like a Lego block, and it says bricks. And the reason why it looks like a Lego block is because when I click it, it will cause our design to be rendered in Lego blocks as well. This is really cool because while it is lower fidelity than our standard design, we now have the opportunity for our students to take something that they might have designed in 3D and render it with the Lego blocks that they might themselves have at home. We know that not all students have access to Lego blocks, but they are a popular toy and an awesome way to learn physical design. So just like with our Minecraft blocks, we can render in 3 dimensions of fidelity, the low amount of blocks, the medium amount of blocks, which gives us a little bit more definition. Zoom in a little bit. And then we can also see the high amount of blocks. So thus far, just dealing with the tool itself, not actually talking about teaching it, we've seen some powerful capabilities that will make 3D design accessible and more real to our students, including, in this case, the ability not just to see a mass of blocks, but to see, if I click on this button that says layers, the individual layers of blocks that will become assembled as students are building their designs. This is something that's really powerful for our students already, and will relate a little bit later on to the actual physical process of 3D printing an object. That's really cool. I always love to show that as a possibility for what we can do with Tinkercad. I will go back to the design space, and I'm actually going to get rid of our lunar lander for now. I'm going to just delete that guy, and I'm going to go back to our standard view. Now, the reason why I deleted our lunar lander was because we now have the opportunity to show off our different shape categories. If we kind of recall back to our slide, there are 3 categories of shapes included in Tinkercad that expand the ways that we can think about what our lessons will be about in 3D printing. Those categories include things that are native to Tinkercad, that's the at home category, and the Oregon Museum of Science and Industry Hangout Space category. The second thing is circuits. This is really maybe some of our older students who are working and building simple circuits and even building with microcomputers, things like Raspberry Pis and Arduinos. And then the third is what we like to call smooth printables. Our lunar lander kind of belongs in that category as well. So on the right-hand side of the Tinkercad workspace, there's a drop-down menu. And when I click on that menu, I now have access to categories. And they exactly what they sound like. Different categories of shapes that I can then drag and drop into Tinkercad to start designing. Tinkercad is different than a lot of other 3D design software in that it is mostly drag and drop. You have the ability to drag in objects and then manipulate objects, as opposed to lines and curves. You're going to be dragging in the whole objects, drag in negative space, dimensional objects, and through addition of positive and negative space, you're able to design really fundamental and really complex shapes. So let's take a look at an example. We're going to drag in, we're going to select the category first, the OMSI Hangout Space, and we're see here actual furniture pieces. The Oregon Museum of Science and Industry a few years ago had a design contest for their interns, and their interns worked together really hard to actually build and pre-designed pieces of furniture. So your students who are working in architectural design or wanting to model a 3D space have the ability to grab an object, in this case, a large seat, pull it into the 3D space. We see it highlighted and drop it anywhere in that space. And there is our couch. Um, I'm going to get rid of this inspector so we can see it a bit better. And this is an object that we can manipulate any way that we like. We can rotate this object. It tells me the scaling is locked, so I can't stretch it and I can't squat it to make it smaller, but I can rotate it about any axis that I want. Let's say that I have to plan a move and I've got to go down that staircase. So instead of screaming pivot, pivot, pivot to my friend, I might be able to think about what this thing is going to be able to do in three-dimensional space. Rotate this couch back and also rotate it around this axis as well. And of course I can change its elevation. So if I need this to go into the air, I've invented or discovered levitation, or I want to drop this into another elevated portion of a design space, I'm able to do that. I'm going to drop this couch back to the design space. And in that same way, I'm able to drop multiple objects. Corner seats and corner couch cushions. The tables I'm not a huge fan of, but I do like house plants. So I might even have a house plant. That becomes a really, really useful bit of design functionality that we have built right into Tinkercad. So I'm going to actually delete all of this now because I'd like to show us another shape category available in Tinkercad. This is called Make at Home. Make at Home, it becomes really, really powerful for us as we design in Tinkercad because as the name suggests, its specific goal is for students to think about designing and building things with household items that they might have. Things like full pencils or even sharpened pencils. We have pennies available to us. Some of our students love using toothpicks to build toothpick bridges. Well, they can go ahead and mock them up right in Tinkercad. Or if they're not using toothpicks, maybe they're using popsicle sticks instead. And there are a bunch of different objects, from chopsticks to whole quarts of milk that barely fit in my design space, so I'll zoom out. We're able to now empower our students to think about the things that they can design and prototype and mock up using household items. I love that functionality in Tinkercad, and I think that's going to be able to make some interesting lesson plans available to you as educators as well. So what I'll do at this point is I'll select everything and delete those shapes as well. One thing that I will mention about the Make at Home shapes is that unlike our Oregon Museum of Science and Industry, the Hangout Space shapes, these I can actually distort and shape as I like. So that's something that students will have to be careful of, that they don't end up making a chopstick that would never exist in real life as they're designing. Or maybe there might be a good reason for them to make that chopstick. But as you're designing, as you're working with students, that's just something that you want to be conscious of. So we've taken a look at the Tinkercad category shapes. I now want to take a look at what are called circuits. And in the circuits, there are two categories, assemblies and components. So the first thing I want to take a look at actually is components. In our component shapes, it is actually what it sounds like, physical components. Some things that your students might have at home, like batteries or basic slide switches, or even whole breadboards. We can actually mock up in three-dimensional space. This is another one of our design functionalities that is going to be useful probably more for our older students who are a little bit more familiar with circuitry and building circuits. If they're familiar with Arduino, this is something they may be a little bit more used to working with. Or if they're working with a more simple circuit, something coming from a 9-volt battery, that may be something that they'll want to design for as well. And you see we've got a bunch of different options here, whether it's our breadboards or if our students are familiar with a microbit, something that many more students are working with. That's an option for them as well. Now that we've looked at components, we also want to look at assemblies. And assemblies become a really cool opportunity because they are exactly what they sound like. If we have motors and other circuit assemblies available in our classroom, say we were teaching a shop or a basic electronics class, we can actually access those assemblies in 3-dimensional space for our students. So we see the space where a coin battery would go and snap into a slide switch, for example. Or if we have a motor that we wanted to build into an assembly that causes something to spin, we can actually build and mock that up in our 3D space. The intent here again is to design something that we can actually 3D print and will be usable by our students. And even more than that, I'm going to highlight all of those and delete them. Even more than that, we're able to install cutouts. This I won't dig into a whole lot today, but imagine taking a solid shape or a shape that did not have space for a switch and cutting the specific space out for the switch that you needed. Tinkercad allows us to do that really easily. So that becomes a powerful tool for us to use as well. Now, the last special set of things that we can work with in Tinkercad, these categories I want to show you are called printables. When we think about our lunar lander, that lives in the printables under the Smithsonian tab. So when I click on the Smithsonian, we can get our lunar lander back, but we can also stay in the Aeronautics Museum and pull out a Bell X-1, one of the first supersonic aircraft. And this becomes a really cool opportunity because we know our students aren't able to travel right now. That school trip to the Smithsonian may have been canceled, but what we now have is the ability to see that object with pretty high fidelity in 3 dimensions. And for our students who want to print them, have an example of those objects. But it's not just limited to technical content. We also have examples of things in paleontology, whether it's a woolly mammoth skeleton fossil, or something from, for example, the industrial area, the industrialized steam era. So we might pull in an example of a Morse telegraph, or if we're teaching about humanities and histories, one of the least impressive presidents, Rutherford B. Hayes. That bust is also available for us to import into our design space and actually physically 3D print. I think, oh, there it is. I was almost afraid that I offended President Hayes there, but he's decided to join us in our 3-dimensional design space. So those things we can pull straight out from Tinkercad and allow us to print them very quickly. There's no design involved for our students. Those are historical artifacts, but we can teach about the ways that these 3D printed objects can be joined together, and in being joined together, how they can be manipulated and actually move. Our dinosaur objects and our skeleton objects are perfect examples of that. So you know that old song, the tailbone's connected to the hip bone and the hip bone's connected to the knee bone? Well, we can actually pull out a hip and a thigh. And I don't think we have a knee, but we do have a shin. And we'll rotate around. What we can actually see, and I'll center our objects, is in zooming in, we have a series of balls and sockets. This socket, and I'll rotate our object so we can actually see that socket. These objects come right off of the printer. This socket would actually connect with the ball on this side of the hip joint. So printing these objects that can actually snap together and rotate and move, kind of like what you would see in a toy doll or an action figure. And I do believe that those are pretty much the same thing, dolls and action figures. So that's one of those hills that I'm willing to die on. But with that being said, we are able to teach our students about the ways not only anatomy works, but how we can build manipulable objects in real time. I have plenty of fun with those objects. Love doing that. So the options are really, really, really wide open when we think about what we can get off of a printer or what we can design in 3D space with our students. So now that we have seen kind of in a larger sense what we can do, what we're able to design and where we can generate lesson ideas, we can continue to go further with how we're going to teach this remotely and think about the instructional model. It's one thing to know how powerful our tool is. If I have a chainsaw, that's great, I can cut down a tree. But if I don't know how to cut down a tree, or I don't know the processes by which it's smartest or safest to cut down a tree, or even why I would cut down a tree, then that chainsaw becomes pretty useless. We want to empower you with the actual model that will make this work in the classroom. And at NextWaveSTEM, we've spent the last 3 years really working hard to develop an instructional model that works in person. Our company started off serving the after school space, and then as we developed our emerging curricula in drones and robotics and 3D printing and artificial intelligence, we moved into the during class time space, augmenting what teachers are doing in their science and STEM classes. And now we've also been licensing that curricula, making it available for you as instructors as well. All of what you see in this instructional model has grown from that growth of seeing what actually works in classrooms and thinking really intently about what we can do to bring that hands-on in-class experience for our students who are working at distance. At NextWaveSTEM, we break it down into 5 steps. And they are the 5 E's. Some of you are actually really familiar with this instructional model from your experience as educators yourself. We want to engage, explore, explain, elaborate, and evaluate. So at a high level, we have these examples of what those 5 E's look like when you're teaching digitally, when you're teaching at a distance. And it really starts through this blended learning model where we have live instruction happening with you as the teacher or with us as the instructor as NextWaveSTEM, or from the perspective of where you're mixing together with your classroom students, helping with the teaching, being guided both by you and in independent work. When we engage students, we want to present them with a real world problem we want to solve. The 3D printer is a tool to produce objects, yes, but those objects that we produce are not just for an object's sake. We want to use them to solve a problem. That's really at the heart of engineering. Secondly, we are doing whole group collaboration in order to explore. We're asking problems, we're digging into the design process. And that group collaboration is moderated by the instructor. So we have the exchange of ideas that's happening, going back and forth between what we've learned. And then we can break out into our small group collaboration. This can be collaboration that's done with our students as even individuals or extremely small groups, 2 to 3, or you might have big breakout rooms where groups are chatting and exchanging and FaceTiming or working in Google Docs. From there, we go back into the live group instructor moderator. That's you as an instructor really at the nitty gritty design and giving your students the ability to follow along or augment what you're doing and modify what you're doing in the design. Um, the fourth thing we want to do is to have your students be able to elaborate, to explain what's going on, and that's the independent work. That gets submitted through your LMS, whether you're using Moodle or Schoology, or if you're using Google Classroom, through Google Classroom, through Google Docs. And then after your instructional time is done, however long that might be, however frequently you might meet, that's where you as an instructor get to evaluate that submission through the LMS and through Google Classroom or the Google Docs or the Office Docs, whatever technology platform that you're using. And that's your real hard and fast opportunity to think about what needs to be differentiated. Where do we go next? So I want to pause for a second and get a little bit of feedback from you as instructors. We have this kind of overarching question with 3D printing. 3D printing, for a lot of our educators, they'll say, okay, this is great. This is awesome. But what am I going to use it for? So let's put that question to you as educators. Some of you have done some 3D printing. Some of you have never done any 3D printing. What's a real world problem for your students to engage with that they might be able to solve with a 3D printer? And coincidentally, this is the part where I shut up for about a minute, and I will let you tell me. So in the chat or in the Q&A, let's take a stab at this question. What's a real world problem for your students to start engaging with? Melissa, really good Good suggestion here. Some schools have done 3D printers or are creating plastic face protectors for PPE. Really obvious low-hanging fruit, right? Evelyn said the same thing, creating face shields. Anitsar said the same thing, creating face shields. Yes, really, really low-hanging fruit. We've heard all kinds of stories of the ways that people in the 3D printing space have been creating face shields. This is very true. And that's what we default to at with NextWaveSTEM as well. Ali actually put a good example, creating wind turbine blades. Yes, for some students who may be in contexts where they need wind power, um, a wind turbine blade or even a prototype for a more efficient blade becomes something that's really, really powerful. With your students who are working with 3D printing, they're actually engaged in student and civilian engineering, civilian and citizen engineering. I'm originally from Detroit, which is in Michigan, and in Michigan, there is a continuous water safety issue. Just yesterday, we saw water safety issues exacerbated in the northeastern portion of Michigan because of flooding and damage and flooding. There's going to be homes that need lead filtration devices and other contaminant filtration devices. Those are things that students can actually mock up and print using 3D printers. But as many of you said, there's also the personal protective equipment with regards to COVID-19. So things like face shields, masks, and even respirator apparatuses can be printed. The components for those can be printed using 3D printers, designed and printed. And there's also something that has received so much attention, assistive touch devices. When we think about keeping our bare hands off of surfaces, a lot of us think about gloves, but We could also build an assistive touch device, something that allows you to depress a button or grab a handle or turn a knob. Those devices are also able to be printed with the printer really easily. Melissa, another great point. Robotics teams need to design attachments and robot chassis parts. Yes, yes, and more yes. Robotics teams love using 3D printers because they can custom design and custom build things relatively easy. No sawing, no sanding, no welding. The 3D printer becomes a really useful way of building precise parts. So these are real world things that your students are able to do remotely um, to work through. And with the NextWaveSTEM, our distance learning classes, that's something that we can do for you as well. So as you're working through your digital classroom, collaboration becomes key. You want to make sure that you know your tool. If you're using Zoom, there's an annotation feature. Know how to screen share. Teach your students how to screen share so that they can show their 3D designs as they're working and they can collaborate on those ideas. You as educators can also jump in and look at their 3D designs as they're designing so that they make sure and you make sure that you're on the same page about the actual parameters of the object that you're building. I mentioned this before as well. Document collaboration becomes really powerful. Something that I suggest for not only STEM teachers, but all teachers that are using Office 360 or Google Docs is to actually assign specific spaces in a document. If each one of your students has a slide to fill out in a Google Doc, that becomes a really powerful collaborative work because your students are not only able to see what they're doing, but they're also able to collaborate and gain ideas and exchange ideas with their other students' slides in the class. That collaboration process is not only exchanging ideas and empowering student voices in new ways, but also is allowing you to see in real time how those ideas get exchanged. For our students who are elaborating, showing and explaining more of what they're doing, and for you as a teacher to evaluate, to be able to think about the progress and the things that have changed, that's where your learning management system becomes powerful. The direct integration with Tinkercad in the Google Classroom means that you can see designs from the same place where you'd be able to see work from any other course that your students may be taking. So that continuity becomes really nice for our schools that are using Google Classroom. And for our schools that aren't, the file format by which 3D prints are saved, the STL file format, can be uploaded into any learning management system, just like a photo or a Excel spreadsheet or a Microsoft Word document. It's a very common thing. You can even email those file formats. So that becomes something that's really easy for you to use and that you can leverage. So I know I've hit you with a fire hose. We've only got a couple minutes left, so I had to kind of accelerate here and get us to the end and make sure that we have some time for you to ask and answer the questions that you might have. The big thing for me now is to talk more about how NextWaveSTEM can help you. And the first thing that we can do for you is the thing that you're doing right now. NextWaveSTEM is running professional development sessions throughout the course of the summer. We have sessions scheduled until the 4th of July. And while we can't foresee the future, I am pretty confident in saying that we will have sessions continuing past those. Our intention is to continue to offer those sessions for free, to continue to make those professional development hours available for teachers because we know that you need the resources and we want to help. So as we're continuing to build your skills, we would love to have you with us. The second thing that we're doing is through doing distance learning ourselves. If your students need distance learning, whether it's during the summertime, whether you need some help on your end with distance learning in STEM, if you just got too much on your plate to take on new STEM instruction at distance, we can do that for you. And we do that in two ways, both with and without equipment. Students who are participating in our courses can order kits for robotics, where they receive a robot, for drones, where they actually would receive a drone, and for 3D printing, where they would actually get a 3D printer. That paired with our live distance instruction gets your students to where you want them to get to, growing in their exposure in STEM, growing in their STEM skills, learning the tools. The same is available for our students who are completely online with the technology. And in that situation, they'd be using the digital tools. Our app allows students to build and program the robot virtually. We have another app that allows students to simulate flying the drone. And then you also have Tinkercad available in 3D printing that allows them to design in the three-dimensional space and even to print and receive that option, that object that they've printed. I see a really good question here about the price of the STEM kits, the hands-on experience. This is where I will direct you to Segundi Chigani. She is our school partnership, and she can get you more information on the pricing. I'm also going to have her drop her email in there, but Melissa will make sure that we reach out to you and get you that price as well. For your students who don't have a 3D printer at home, who don't have any access to any way to actually print the school's clothes, they can get there from the design space, and this will be the last thing that I show in Tinkercad today. They can take an object. We'll go back to our Smithsonian, and we will grab the command module again. That is my absolute favorite. We'll see if it is cooperating. So now that our command module is in the space, we can actually export to an outside third-party 3D printer. Our students can go to a printer like Print a Thing, and kind of that same cooking show style. I've already got an order pulled up. It takes your physical object that you design in 3D space. You can adjust your settings that I won't get into too much detail, and fill and layer thickness, and get a quote and get your object shipped to you. So whatever student is designing in 3D space, they can click 2 clicks, and then their parents can order this object to come to them. Or they can even upload other parts and create a whole order. Some of these sites are a little backed up because they are fulfilling orders when it comes to PPE, but this becomes a really powerful way for students not to just stop short of 3D printing, but actually getting their object. Something that's really cool for your students to do. So with that being said, the hands-on experience, live instruction is something that we really have, really are excited to make available to you. The other thing that NextWaveSTEM can do for you is actually train your school in our curricula. We know that the fall is coming. Things are way up in the air. NextWaveSTEM, as I mentioned before, our wheelhouse is in training your teachers and providing you with the resources that you need in order to become a proficient STEM teacher as well. So once again, contact Segundi. We have courses K through 12 in emerging technologies like drones, robotics, and AI, and we can put you on the right track for the fall. So I want to pause. We technically only have 1 minute left, but there are questions. Ali asked a good question. Do we have access to all of the training session recordings? Ali, the answer is yes. When you, because you've attended this webinar today, you'll be receiving a follow-up email, and that email will include a link to the recording of today's webinar, and there's going to be a playlist link that allows you to access our previous webinar recordings as well. And that goes for all of our participants on the line today. Are there any other questions with the little bit of time that we have left? And there, of course, are no bad questions. Ah, what is the most important thing for us to remember as we teach students remotely? We want to continue to build connections, and we want to continue to establish those connections. As awkward as it is for us as teachers not to be able to see our students, to miss that physical interaction, to not be able to give them that hug or that high five, they are still there and still wanting to be with you as instructors. Build that connection with your students. Check in with your students at the course, at the beginning of the class. Um, Call on names. I'm sure we've seen those memes of people hanging pictures of themselves in front of the computer screen to simulate that they're paying attention in class. It's a little bit of an adjustment, but work through that list of students and get your students involved. It's really easy to tune out, but it should be an interactive experience. And just a little bit of extra time really lets your students know that you care about their instruction and that they're still with you. They're still your students. It's a very good question. Well, we have elapsed our time. We're actually a little bit over time. So I want to say thank you so much for joining us here at NextWaveSTEM. This is my contact information. I am Desmond at nextwavestem.com. If you have any questions about our program, any questions about our curriculum, you want to dig into the weeds, I am a curriculum writer for NextWaveSTEM as well. I'd love to answer any questions. We're on Twitter, Instagram, LinkedIn, and Facebook. No TikTok yet, probably honestly no TikTok ever, but we would love to connect with you. Until we get a chance to speak with you all again on Tuesday, thank you so much and have an amazing day.